Hi guys, welcome to part 2 in the Cisco VLAN series. This video I'm hoping won't, I try to keep the videos as short as I can, and hopefully this one won't run too long, but there are a couple things we can discuss here that may get a little long-winded, but I'm going to try to avoid that at all costs. In part 1, we configured an accounting VLAN and a marketing VLAN on a single Cisco Catalyst 2960 switch here in building 1. In this video, we're going to expand our network to building 2 by connecting another Cisco Catalyst switch in that building to our existing switch. In the new building, we're also going to have an accounting user and a marketing user. So we're going to need our VLANs to span across both switches. And in order for that to happen, we have to use what is called trunking. As I mentioned in part 1, a trunk is basically a link between two switches. However, that statement wasn't totally accurate. You can have a link between two switches that is not a trunk. The link can become a trunk in one of two ways. You can either manually configure the ports on each end to be trunk ports, or the switches can auto-negotiate that connection to determine whether they will form a trunk. But before we get into that, let's talk about what a trunk is and talk about why we need them. A trunk is a link between two switches that can carry traffic from multiple VLANs. So in our case, we're going to need a trunk here because we're going to want to carry traffic from VLAN 10 and VLAN 20, whereas these ports here that we set up our PCs on, they're access ports and can only belong to one VLAN. A PC, let's elaborate on that a little bit. A PC itself, it's not VLAN aware. It has no idea what VLAN it's in, and it could care less. So for that reason, if we want the traffic from PC 1 to be on a specific VLAN, we have to configure that port to be on a specific VLAN. If this port were a trunk port, let's say, and it could carry traffic from any VLAN, and we plug in this PC, well, how does the PC doesn't know which VLAN it's on, so and without the port being assigned to a specific VLAN, then we've kind of defeated the purpose there. So that's why the access ports are allowed to one VLAN only. Now in our example, like we said, we have two VLANs configured. We've got VLAN 10 for our accounting users, and we have VLAN 20 for our marketing users. We're going to add another switch, and our link between it has to be a trunk port in order to carry multiple VLANs. So let's put on our thinking caps for a minute, because they've made it probably a little more complicated than it needs to be, but there are 4 trunking modes. One of them we have already learned about, and that is access mode. Access mode means the port belongs to one specific VLAN. So obviously these are the ports that your PCs, your printers, your servers, that type of thing plug into, or you're going to set those ports as access ports. The next mode we're going to talk about is trunk mode. Now this is when you configure a switch port specifically to be a trunk port, and it's a trunk port period, and there's nothing that's going to change that unless you manually go in and configure that port to be something other than trunk mode. The two other modes we're going to talk about are dynamic auto and dynamic desirable. These modes can dynamically negotiate whether the port is going to be a trunk port or not, based on what the switch on the other end is set to. Dynamic auto does not actively seek to be a trunk. It is never trying to be a trunk, but if the switch on the other end wants to be a trunk and is actively seeking to be a trunk will be formed. So dynamic auto kind of just sits there and just waits until somebody asks it to be a trunk. So in other words, if switch 1 had its port set to dynamic auto and the port on the switch 2 that it was connected to was in either trunk mode or dynamic desirable, a trunk would form between the two. However, if the switch 1 port was set to dynamic auto and switch 2's port was also set to dynamic auto, a trunk would not be formed because neither of those ports are actively trying to become a trunk port. Dynamic desirable is actively trying to be a trunk port. So if the port on the other end is either auto or trunk mode, a trunk will be formed because the dynamic desirable is sitting over there going, I want to be a trunk, I want to be a trunk. So if it meets one that is a trunk, all right, cool, we're a trunk. If it meet one that is an auto will be like, okay, if you want to be a trunk, we can be one, great. So that's basically it. Now, the last thing I want to talk about in regards to trunking modes is a best practice, and I think the best practice is to put all your ports in access mode right out of the gate. Turn everything into access mode, and then when you know you have a port that you want to be a trunk port, manually set it to trunk mode. And here's the reason I say that. Let's have an example here where this accounting VLAN is has a lot of information that you don't want to get into the wrong hands. So we've got a few users that have access to that VLAN 10, but no one else should ever see be able to get to that VLAN. Now, by default, a 2960 switch, all of the ports are going to be set to dynamic auto. And that's good to remember. If you're taking your CCNA exam, you may be asked about that. It's when I'm making this video, it's 2015. The current CCNA, I believe, is based on the 2960 switch. Previous version of the exam, I believe, were based on the 2950, and the default on that is dynamic desirable. So you may need to know the difference there. But on a 2960 switch, the default for the ports is dynamic auto. Now, why is that a bad thing? Okay, let's say we've got these guys in access mode on VLAN 10, and a hacker comes in, sits at an empty cubicle. He brings his own Cisco switch, and he sets his port to trunk mode, and he plugs into an empty port on your switch. What's going to happen? Well, he's set to trunk mode. Your switch is set to dynamic auto, so a trunk is going to be formed. So that hacker can, at that point, configure any port on his switch to be in VLAN 10. So now he has access to VLAN 10, which is supposed to be totally secure. So for that reason, that's why I say, put everything in access mode and then only turn on trunk mode when you know that you need it. Okay, so that was the part of the video that I thought was going to probably take a little too long, because I know watching these videos, after about 20 minutes, people start nodding off, including myself. So let's go ahead and start talking about how we're going to configure our network here. All right, the first thing we're going to do is take a look at switch 1, and here's another command for you. Show IP interface brief. So that's just going to show us the ports we have here on our switch. It's a bunch of fast Ethernet ports, and we've got 2 gigabit Ethernet ports. So we're going to use gigabit Ethernet 01 on this switch and on the other switch to be our trunk link there. So now let's go into configuration mode. Or no, sorry, I'm going to show you one other command. Let's since we know we're going to use Gigabit Ethernet 1, let's say show interface Gigabit Ethernet 1 and then put switch port at the end of that command. And it shows us some interesting info here. So here's our mode. Like I said, dynamic auto by default. Another thing to look at here, the encapsulation. There are two different encapsulation modes that you can use. There's .1Q and there's ISL. ISL is a Cisco proprietary encapsulation method. You don't really see it that much. .1Q is kind of the industry standard. I believe now even some of the Cisco switches maybe don't even let you use ISL. So just wanted to point that out. You can see our negotiation of trunking is on. But what we're going to do for our examples, we're just going to manually set this mode to trunk. So let's go to configuration mode, go to the Gigabit Interface 01 and switch port mode, and we'll go ahead and type a question mark so you can see what we've got. Access mode we've used before, and like I said, we can manually set it to trunk or we can set it to dynamic. So I'm just gonna show you that dynamic, and we've got the options of auto and desirable. We're gonna just set it manually to trunk mode. And actually what we'll do, this will be kind of interesting, we'll go ahead and show you how the auto negotiation works, but then we'll set this later. So let's see, I may have played around with this one, but let's do show interface Gigabit Ethernet 01 switch port. Yeah, I've already got it set to trunk, but let's do this. Let's change that to dynamic auto. We'll test out our hacker theory here. So we're going to connect our Gigabit Ethernet 01 to Gigabit Ethernet 01. And we'll give that a second until we see these turn green. And here's a command you might want to memorize. Show interfaces trunk. That's going to show you the ports on your switch that are currently trunking. And there, remember that one's set to auto. The one on the other end was set to trunk, and it is trunking. So we've got a trunk formed. So if this switch had been a switch that a hacker brought in, he'd be able to get into any VLAN he wants from that point. But let's go ahead and go with my best practice here, and we're gonna just set it manually to trunk. There we go. Alright, so we've got our trunk formed. So next step is we're going to make sure I've got my IP addresses are already configured. So let's go ahead and connect our PCs. So PC 5, we will connect to port 5. PC 6, we'll connect to port 6. Now at this point, let's go in here And you can see we're on the same subnet as the PCs here in VLAN 10. But we haven't put our PC5 in any specific VLAN yet. So what VLAN would it be in? It would be in VLAN 1 by default, right? So our ping fails. So let's go in here to port 5, switch port mode. We want to keep it in access mode, and make it a member of VLAN 10. And that's interesting too. Brand new switch, we haven't configured any VLANs on it, right? So it doesn't know about VLAN 10. So now VLAN 10 has been created, and this is a member of VLAN 10. Now another thing we'll probably talk about in a later video is there's actually a way to make these switches learn the VLANs from the other switches on the network. That's beyond the scope of what we're talking about here, but just to let you know that that option is there. Another thing, if your network's small enough to get away with it, keep that feature off. Alright, so let's go ahead and try it again. Look at that, we're pinging a PC on VLAN 10 from our location down here. It's pretty cool. We're you know, we had talked about one of the reasons for VLANs is that we can group our PCs logically instead of geographically. So, you know, this building 2 could be, you know, in another state, and here we are, basically this PC appearing. You know, you would think it was physically on the same network, but it's not. They're in the same subnet, but they're, you know, logically grouped instead of geographically grouped. Alright, so let's go ahead and do the same over here. Same thing, it didn't exist, but now it does. So let's show VLAN. Got 10 and 20, and if we want to, just to be consistent, we'll go into VLAN 10, name it ACCT, and then we'll go into VLAN 20, name MARK. There we go. And we'll also test this PC. Make sure we can ping something in the other location. There we go. And should not be able to ping anything in VLAN 10. I'll even try to, whoops, I did subnet 20, but it should have been 10. So we'll try to ping somebody in the same office, and yeah, it fails. Alright, so there we have it. That's all for video 2. Haven't decided yet whether there's going to be a actually I will. We'll go ahead and we're going to have another video in this series. What we're going to talk about in the 3rd video of the series is what you would do in the situation where, you know, you're trying to limit broadcasts between these two VLANs, but you still have a need to be able to get from one VLAN to the other. Let's say all your servers were in VLAN 20. You may not want all those broadcasts that the servers are sending back and forth to each other to, you know, be seen by these PCs, but these PCs have to access the servers to get their files off the servers. So we're going to talk about how you would get from one VLAN to the other. Big hint is it's gonna need to have routing involved. So we'll talk about that in the next video. Thanks.